Recent events have led to an increased demand for distance education. Cyber-physical systems and computer science education are especially viable for learning remotely, but not all topics are easy to cover at a distance. This demo will focus on a simulation platform designed to improve distance education on distributed cyber-physical systems and robotics for K12 STEM classes. Educational robots present multiple barriers to entry for classroom use. There's a cost for purchasing robots, maintaining them, even a cost to set up activities using them. Teachers may also need to become experts in repairing robots to keep their classes running smoothly. Simulation can and has resolved some of these issues, but by combining it with collaborative tools and a novice-friendly programming interface, we can reach a wider audience while also demonstrating a wider range of topics. Students using this platform will be using the NetsBlocks programming language. NetsBlocks is a block-based language based on Berkeley's Snap language. But where Snap focused on functional programming, NetsBlocks focuses on distributed computing features. Students can collaborate remotely, synchronously or asynchronously, their programs can easily send messages to each other, and they have easy access to web services all through block-based abstractions. NetsBlocks has an existing robotics service known as Roboscape. While many traditional educational robotics platforms have students write firmware for a robot, to continue NetsBlocks' focus on distributed computing, Roboscape has students interact with robots through the same abstractions applied to web services. As NetsBlocks code runs in a browser, commands are sent to robots over the internet. This project, Roboscape Online, allows students to both access simulated robots and collaborate or compete in their use. When running the client software, students are connected with their classmates in a shared virtual space, running the scenarios requested by their instructor. Because the client was designed using a commercial off-the-shelf game engine, tools and documentation for educators or students to create their own scenarios are readily available. This new system brings students together, despite them potentially being a vast distance apart physically. NetsBlocks enabled remote collaboration for block-based programming. Roboscape Online extends this to robotics education as well. Let's see a few example scenarios. This first scenario is based on a challenge previously given at our summer camps. With physical robots, students were assigned to use their robot to push boxes out of an area. With virtual robots, we can make this experience a bit more exciting visually. On the screen now, you can see a robot performing this challenge being driven by a remote control program written in NetsBlocks. This scenario will be available as collaborative, cooperative, or individual experiences based on the teacher's preference. In addition, a teacher can choose to assign this task as requiring robots to perform it autonomously using the robot's sensors, or driven manually by a student as seen here. Code used for the simulated robots will behave nearly identically with a physical robot. The second scenario presents students with control over a traffic signal in an internet-connected city. Each direction in this simplified intersection has sensors to determine where cars are waiting. Students are tasked with creating a controller program for the signal to improve the flow of traffic. Both the sensors and signal are exposed to NetsBlocks as web services, so students have blocks available to send commands to change the light's colors. On the screen now is a simplified program which pulls the traffic sensors in one direction and changes the light based on the vehicles present. We hope this system will allow us to offer robotics-based STEM education on more topics to more students by removing more of the barriers to entry. Thanks for watching, and for more information on this project and related projects, please visit netsblocks.org. We would also like to thank our sponsors at the NSF and NSA for their continued support on our projects.